for future reference so everyone can take a look at it later and maybe be well prepared with the regulations. I would like to say in a sort of apologetic way as to why am I speaking English. I am currently in the process of studying Polish, so przepraszam regarding that. Uh, Today we have an interesting topic to speak about, which is the Formula Student Regulations 2025. Why am I saying 2025? The Formula Student Regulations, in a sort of way, are quite a live matter and change year to year. So, uh, first of all, I'd like to start as to who am I and why am I presenting this. First of all, I am the Formula Student Alpe Adria head scrutineer, meaning that I organize the scrutineering process at Formula Student Alpe Adria. And from recently, I am a student at the Warsaw University of Technology as well. As to my joining the team, as to why I am a part now of this team. In regarding to that, I have a lot of experience in the motorsport world as being the president of the Technical Commission, which is the governing motorsport body in my country, which is North Macedonia. In 2021, I got my FIA scrutineer license, which with a grade A, meaning that I am eligible to be even a scrutineer at Formula One, although I've been doing only GT races and hill climbs in the past few years. For the past 2 weeks, I have been not available, as to sort to say, to the Formula student community because I was obtaining my FIA steward license, meaning that from this month, from this December, I am officially also a FIA steward and a part of the FIA University graduate program. Previously, prior to my organizing capabilities in the motorsport world, I was also a part of a TCR Europe team as a team member, and also a founder in one of the biggest motorsport NGOs in my country as well. My story in Formula Students starts with actually beginning of a team, sort to say, in a university in North Macedonia. But enough about me. I would like to say about the topic today. The topic today is rules and compliance above all. Technical inspections are a crucial part of the Formula Student competitions. You may ask yourselves as to why we are putting so much focus into compliance with rules and technical inspections. Why do we want to make it hard for teams to pass scrutineering? And the whole process can be a lot of stress for the teams, especially for the persons. We are going to talk about this later, about the persons who is responsible for the technical inspections. There is an interesting bunch in the Formula Student community, which is the FSG competition. The FSG competition can be said to be one of the oldest Formula Student competitions, which are a group of people who decided to make this one of the biggest and most popular events. They are investing a lot of time and money into it, as well as resources. They developed a set of rules back in the day to which every European competition except the UK one goes to, meaning that they are the founders, sort of way, of the Formula Student regulations. The Formula Student regulations have one goal. The main goal for that being said is to have a smooth competition for every single team where safety is the number one priority for it. In this rules, there are a lot of topics that are covered. The topics we are going to discuss them later on as well, are essential for you to understand as to design a good car, as to design a safe car, and as well as for the design process to go smoothly and for you not to have any problems during the competition itself. Teams invest a lot of money, especially time, because I can safely say that time is also a resource into the car, and it's a pity for a team to design a car that is not rule compliant and be ruled out of the competition where they spent hours and hours designing it. Understanding the sections of the regulations. I'm pretty certain that all of you have heard about the FSG regulations, and I will show you later on how to find them, especially for the new guys in the team. I would like to show you how to navigate the FSG website. It can be tricky at sometimes, especially when a lot of documentation piles up there. The FSG is a document containing around 130 pages divided into sections. We have section A, section T, section CV. The orange sections, which I've ruled out because they are a part for the electric vehicles and autonomous vehicles, as to say this team Wood Racing does not have any electrical vehicles. Warsaw University has one, but it's not our team's vehicle. Section IN, which is the technical inspection, and section D, which describes the dynamic events. In section A, you can, when you open the regulations, I hope everyone has at least looked at them once in their lifetime. In section A, you can cover the competition overview, meaning how the competition is structured. Everyone should know that the competition is structured in such a way that there are statical disciplines and dynamical disciplines, meaning that some disciplines you drive in them. You have parts where a driver actually enters the car and drives around. We named these as sort of tests due to not having any problems with the law itself of the competition, not to collide with the state laws of the countries in which we organize them. There are also the team requirements, which state that each member of the team must be a member of a university and graduate or postgraduate programs. The documentations and how to name them, which we had a lot of funny situations, especially in Alpe Adria this year, and the rules of conduct. In this section, there is an interesting regulation that basically gives the scrutineers and the officials sort of a god power to rule over the team members in any way, meaning that if an official decides to be rude in a sort of way, it gives him the ultimate power, and we strictly stand by it, especially since we are striving to be a system of expert people in the field working to ensure the team's safety and compliance. The technical regulations in section T, you can find them from page 30, I think, somewhere there. Even myself, I do not know the whole regulations by heart and anything. Of course, it's a matter of navigating it rather than just knowing things. In section T, you can find the general requirements for the vehicle design, meaning how the overall vehicle outlook needs to have. You can find the safety regulations, such as critical fasteners, critical safety systems, and so on. I'm going to talk about this later as well. You can find the chassis requirement, which there is actually a change for this year in the SE3D part of these regulations. You can find the powertrain regulations and the aerodynamics, the regulations. A note to mention is that during the scrutineering process, different competition, it is conducted in a similar but quite different way. Why am I saying this? It's because some competitions pay attention to certain things that others don't. I will give you an example, as I was a scrutineer this year at Czech Republic and at Alpe Adria as well. At Czech Republic, in the sheets that they give out during the competition itself, there is like a checklist for teams that need to carry it with them for the scrutineering process. There are two types of checks on the checklist itself. You can find circle and triangle ones, meaning that one is up to the team's responsibility to be compliant at all times, and the other one must be checked by an official. Why is this? This is due to saving of time. The scrutineering process, we've had cars that we've scrutineered for maybe over 6 hours even at some competitions, especially the cars that have a certain amount of problems. We try to explain to teams what the problems are and how to fix them. In a sunny day in the heat, it's basically not very good to be inside a tent for over 6 hours and digging through your car. We are going to talk about this a bit later on. The section CV is specific to our team. Why? Because it details the specific requirements for the vehicles powered by internal combustion engines, meaning that electric vehicles do not need to follow these regulations. Of course, the combustion cars have a low voltage system where they need to comply with some parts of the regulations for EV cars, but it's a whole different topic and a whole different section in the regulations itself. Section IN, Technical Inspections, describes the inspection process. I will explain to you in detail how the inspection process works. Why is it critical for you to know how the inspection process goes? It is critical for you to know how the inspection process goes for you to design the cars in a proper manner. Why am I saying this? Most teams like to get an advantage in a sort of way. Of course, higher budget teams pay more attention to this and more time. But knowing and navigating the whole process allows you to find the loopholes in it. We've had certain situations where even the officials and the organizers of the competitions didn't have a clue as what to do for the issue. This is because the team usually found a loophole that was not stated in the regulations, and we had to think of a solution on the spot itself. This is not very good for either the team nor the organizers themselves, but it usually results in a decision favoring the team, basically letting them to drive. Section D is the dynamic events. We are going to talk about the dynamic events later on, but shortly I would like you to acknowledge that especially for the new teams, I've had an opportunity to chat with a couple of you. This is not a Formula One race. This is not 20 cars going around in a loop and racing. No, quite the opposite. It's a design engineering competition. First of all, the task is to design and manufacture a car that's good, that follows motorsport principles. Events such as the acceleration or the skid pad are essentially a test to see how well you designed your car, how fast your car goes, how maneuverable your car is. The autocross and endurance are of course tests as well, but in a more sporty way, so to say, as the real competition happens there between teams. That's why basically teams live for the autocross and especially endurance competition. The efficiency is a part of the endurance competition as well. Of course, in Section D, it also includes the scoring and penalties, which unfortunately I had the pity to do for the last 2 years at Alpe Adria, 2 teams giving out penalties, which is not a light process to do. I will explain to you how the penalty points are determined. First of all, we are going to get a simple overview of the technical inspection process. The technical inspection process, basically, I have divided it here into 4 different topics, although it's not 4 different processes. The pre-inspection, the first thing that you do on the competition itself is have you are registering yourself. I know the pre-inspection process this year was a nightmare for teams, especially at Alpe Adria, because we had a lot of teams and not enough pre-scruties to do the pre-scrutineering, but it's an issue that we are actively trying to fix. The pre-inspection is basically a thing where a scrutineer comes over usually to your pit or tent, where they register the amount of tires that you have. They register also the driver's equipment, meaning it is compliant with the rules, with usually FIA or SAA standards there. You can find the standards in the regulations themselves, although the FIA ones are usually 88 something number, where if the year is after 2001, it's still valid and you can still use it. It's in the also in the Formula Student regulations mentioned there. The tires need to be 16-inch wheels. Basically, we mark the tires as well, as it is forbidden for teams to swap out tires. They can only use one set of dry tires and one set of rain tires. We usually let teams for the braking test, because it is not a part of the scoring system, it's only a way to pass technical inspection, use old tires, meaning they can swap out the tires that they're going to use for the competition. Accumulator and electrical, the process basically continues once you pass pre-inspection for the EV teams to accumulator and electrical inspection, but I am skipping this as well due to the fact that we are still a combustion team, one of the good left. Next up, after the teams pass the Accu EV Scrut, is the mechanical inspection. The mechanical inspection is the detailed inspection of the vehicle mechanics, in sort to say. Why am I saying mechanics? I'm saying mechanics because we are inspecting every critical component for the car to drive. We are inspecting also every safety factor that is mentioned in the regulations themselves. There is a lot of data in the mechanical inspection, but if you're breaking it down to systems, basically it's an inspection of the powertrain, of the suspension, of the steering, of the aero devices, and so to say the chassis and the safety features of the vehicle. After you pass mechanical inspection, then you move on to the additional tests, as I say, which is the tilt test. The tilt test is a test where we see if the vehicle rollover protection works in a sort of way, and also that the vehicle doesn't leak when cornering. After that, you move on to weighing, and once your car is weighed up, you can go to noise test. A rain test is not applicable for the combustion cars, and after that you go to brake test. We are going to talk about these tests later on in detail and how they work. The general rules for technical inspection is passing the requirement. The vehicle must pass all parts of the technical inspection before participating in dynamic events, meaning that the vehicle is not allowed without inspection to go to any of the dynamic events. You cannot run autocross or endurance without passing the technical inspection itself. Why is this? This is mainly a safety feature. We do not know how you designed your car, whether your car is safe to drive or not. So that's why it is mandatory for you to pass the technical inspection before you actually race. The second thing is vehicle condition, that the vehicle must be presented in a ready-to-race condition. What does this mean? This means that your vehicle, once you come to the technical inspection, must be ready to race, as you would roll out on track itself. The compliance responsibility is that the teams are responsible for ensuring their vehicle meets all the requirements before inspection. If you're not prepared, don't come. That's the thumb rule, as this saves you a lot of time and also us a lot of time. Of course, teams usually, what the issue is, are not prepared with documentation. Documentation is essential for us to know how your components work. You bought some wiring, or you bought some plumbing, as I say, and you don't have a datasheet for it. We don't know if it's PTFE. We don't know if the fuel will corrode it and basically burst your fuel lines. We don't know if your fuse is going to hold the specified amounts of milliohms. We do not know if your firewall is also fire resistant. That's why it's essential for you to keep track of these data sheets. Once you decide that you're going for a manufacturer component, always ask for a datasheet. I cannot stress this enough, because it's really important that you follow it. You're designing a part, you decide to implement OEM part, originally manufactured part. There is always a datasheet for it. Even highlight the section where the standard is. Highlight the section where it says that it is PTFE. You have the time now. You won't have it during the competition. Each team member must keep track of this. And once the General Assembly goes into place, then I would advise to going to physical binder with every single datasheet, or a tablet or a laptop with a good database where you will keep your datasheets in it. And of course, the fourth point is your vehicle after you pass the technical inspection. It doesn't mean that you can disassemble the whole vehicle and do modifications to it in a certain way. Yes, specific modifications are allowed, but safety critical modifications are strictly forbidden, and the vehicle will always have to be compliant with the regulations themselves, meaning that throughout the whole competition the officials reserve the right to pull you to the side and inspect your vehicle. Yes, we don't do this because it's not fair to every team, but we have the right to do it if we deem that it's not safe. Inspection requirements part 2, as I already talked all about the documentation and the vehicle preparations. All components must be clearly visible for officials without using instruments. What does this mean? This means that you cannot get out the angle grinder and cut a profile out of your car for us to see the firewall. No, you design it in a certain way where it's removable. You remove parts of the car using only handheld tools. In certain cases, of course, you use some power tools for removing certain stuff, but other than a handheld drill, I don't think that any competition will allow you to use any other power tools. And of course, the vehicle must be in ready-to-race condition. The teams also must submit the required documentations on the FSG website. We have a central system, the European competitions that we've developed throughout the years, where we check the SCS and impact attenuator data on an online platform that reviewers from every single competition are in this process. Of course, I am skipping the accumulator and electrical part of the inspection. We are moving on to the mechanical inspection details. As I mentioned previously, the structure of the regulations themselves are the chassis and structure, the driver safety, vehicle systems, and aerodynamics. The chassis and structure verifies that you designed your chassis in the way that we like, in a way that it's necessary for you to follow for your own safety, first of all, and then for your engineering practices, for your engineering work, to show us that you did the engineering work, you did the calculations, you did the welds correctly, you did the triangulation of segments correctly. It's really important that you follow these steps as to advancing your career in motorsports. These are the pillars of design. These are the pillars of how you manufacture parts. Of course, the second pillar is the driver's safety itself. Inspection of the cockpit, meaning that inside the cockpit, a live person is sitting. If that live person makes a human error, which is highly possible, the car needs to be designed in a way that it's going to save him. If you crash with 80 or 90 kilometers an hour, you're most likely getting fractures, you're most likely getting injuries that are deemed as tier 3 in the FIA, as we say, and even can result in death. That's why you sign the waivers of liability on the competitions themselves. Of course, the whole goal of this is for us and for you should be to prevent this. Driver restraints, meaning the harnesses, of course, they are the key feature in the safety system. If you crash, you won't fly out of the car, you won't break your neck. The restraints will be mounted in a way that when you crash, damage to your body is minimal. And you should keep in mind these parts when you are designing the car itself. Where do I mount the driver restraints? How do I prevent the driver, if he hits, to break his neck? Of course, when we are writing the regulations, we keep this in mind as to you to follow, but also it is the team's responsibility to be rule compliant, but also understand the regulations. You may ask yourself, I'll give an example now. I've had this question asked to me. Why is the harness mount, the shoulder harness mount, at a certain degree? It is mounted in such a way that calculations have shown, we did this, the calculations with the FSG team, have shown that minimal neck damage will be between 10 degrees above and minus 20 degrees below, depending, of course, on the driver height itself. And of course, the visibility requirements. You cannot design a system where you cannot see. It's bad engineering practice. Also, there is a regulation, there is a rule stating that if we deem something as bad engineering, we can tell you to change it, or we cannot let you drive with this bad engineering habit. Of course, the third part is the vehicle systems, such as brakes, suspension, and steering. Does your car turn? If you were to go on track, will your car go straight in a straight line, or will you turn? Of course, designing a car is not an easy task. It's a really time-consuming, really mindful work. But always keep in mind one thing. Why was the rule written? 99% of the rules were written for you to be good engineers and for your own safety. We are going to have a small case study later on in the presentation where I explain to you why certain rules are the way they are. And of course, the aerodynamics compliance. Aerodynamics are carbon fiber. Most teams use carbon fiber. If you were to hit at high speed with carbon fiber, you would have a carbon bomb where carbon fragments would go all over the place, where sharp things are flying around. This is dangerous. Dangerous to you, dangerous to the audience, dangerous to everybody on track. And of course, it's time consuming if you crash and there are fragments everywhere. The case study that we are specifically talking about today is, of course, the Aero device. The Aero device vertical height, we are going to talk about it, and of course we are going to talk about the edges and radii. Why? I want you to see how officials think, and I want you to continue doing this practice later on. When a new official comes to Formula Student competition, we try to educate them on how to think about the regulations and how to implement them. Although this sometimes may not work, as they are all engineers who think they know better than the organizers themselves. But we try to give them an edge on how to handle matters like this. Devices forward of the vertical plane through the rearmost portion of the front face of the driver head restraint, excluding any padding set to its most rearward position, must be lower than 500 millimeters from the ground. What does this tell you? This tells you that if you were to crash on the side and something is above 500 millimeters, would it slice your head off or not? Of course, the rule itself is so that the driver and the seating position is, in case of a crash, it would do minimal damage to you and minimal damage to any part of your body. That's why that part of the aero devices, meaning the diffuser, the side diffuser, just to simplify matters, must be lower than 500 millimeters. The rear device must have a maximum height of 1.2 meters above the ground, of course excluding end plates, and the front devices a maximum of 250. On these two matters, you're not going to crash rearwards, of course, but if you were to spin out, there is a possibility that you are going to crash rearwards. Will this slice your head off or not? That's the way of how you need to approach stuff. Second part is, of course, that we test you on how well you can design a car. And the front must be 250 above ground. Will this slash your tire if the aero were to fail? Will this hit you in the head if the aero were to fail somehow? The edges and radii regulation specifically has a purpose for you to not have sharp edges. We don't like sharp edges, especially that can come in contact with a pedestrian. There was a rule that sharp edges, we had a few situations where officials actually cut themselves on sharp edges on the aero device. Carbon fiber can be really, really sharp at some points. Edges that could contact the pedestrian must have a minimum radius of horizontal leading edges, meaning that the horizontal edges have to be at least 5 minimum, but this is an old rule actually that was removed. I think now it's only the 3 millimeter and 1 millimeter, or 5 millimeter or 1 millimeter. I am not sure. I will have to check this, as I've got this from an old technical sheet that I have in my computer. But I am pretty positive that this rule was changed for this season, or yes, for this season specifically, meaning that horizontal leading edges need to have 5 millimeter. No, sorry, 3 millimeter, and all other edges have to have a minimum of 1 millimeter. The intent of this rule, when you start designing an aero edge specifically, you should bear in mind that it's the safety of the people touching the car. You show your car to a lot of sponsors, you show your car to a lot of children, you do events with it, you do everything. Everyone wants to touch the car, everyone wants to see how you did. Will they cut themselves? Will an official, when they are giving you the green flag standing next to the car, if he were to make a mistake, will he cut himself? That's how the approach to the rule is, and that's how you should be designing. Powertrains. Fuel tanks must lie within the major structure of the chassis with full side impact protection and firewall between the fuel supply, essery and driver, a minimum 50 millimeters away from the exhaust components. I think that this rule is pretty self-explanatory. If I were to crash, will I blow up when the fuel tank hits anything? That's why it needs to lie within the surface envelope of the structure itself. If you were to roll over, will fuel spill on the driver and light you in flames? When stationary, will the fuel tank itself catch on fire due to the exhaust being too close to it. That's why we design in a certain way to be safe. Safety, of course, safety. I may have mentioned it 100 times for now. It's the most important thing. We are designing stuff to be safe. We are designing stuff not to harm ourselves. Of course, everyone has a mission in motorsport to reduce motorsport-related deaths. We are in the motorsport business, of course. Scatter weight, this is obviously a mistake. Belly pans, of course. Belly pans in total of minimum 2 vending holes and no holes. I've obviously made a mistake here in the case study, but of course it was my intent to only mention the belly pans themselves. If you were to have a failure of a container containing liquid in it, will you like your driver to be soaked in the liquid itself when he's driving the car, especially radiator fuel, radiator liquid, which can rise to around 60-70 degrees? Of course, you don't want that. Of course, our mission is to as soon as possible get that liquid out. That's the goal and intent of the belly pans themselves. And that's how you should be thinking during the design process. Of course, where will liquid accumulate? Okay, there. And then I drill a hole there as to drain the liquid. Ready Steady does it. Of course, you should always be prepared to disassemble the car and follow the officials in a certain way. That's why you design stuff to be easily accessible, to easily get it off the car, and for the official to be able to see the component or anything related to the component. The whole process can be a lot of stress for the guys doing it. I know this because I am on the other side and I see their stressed faces season from season. Especially when they have a time limit on it, because it's not the officials' job to keep track of time, but when the time ends, they kick you out and you need to go in for a rescrut. We've calculated that if your car is fully compliant and designed in a way that you can disassemble it, a certain amount of time is sufficient for you to pass technical inspection. This has been tested and this has been proven to work in a sort of way. So that's why when designing a car, do not put 25 bolts if 4 are necessary. Make it as simple as possible for you to disassemble it. Of course, you should also bear in mind the safety factor in there, but simple and safe is the way to go. And do not rush during the technical inspection itself, because stress is not your friend there. The tilt tests and weighing. The tilt test setup, the vehicle is placed at a tilt table at 60 degrees. Yes, this is quite scary for the driver themselves. We've had a few situations where the drivers were actually scared to go on the tilt test themselves. But this is for us to test your rollover protection. For if your car has a low center of gravity, will your car flip over? And to test the fuel leakages. You need to have closed systems designed in a way as to not spill on track. When you are cornering, you are experiencing a certain amount of G's, certain liquids are going left, right, and everywhere. So we don't want this to overflow somewhere and basically spill on track or on the driver or harm the environment in any way. Of course, after you finish the tilt test, you will go to the official weighing on the official weights of the competition and take your measurement. This is crucial for us to determine whether you change components or not. After the competition has finished, you should be reweighed to check whether you are the weight itself. Of course, you can vary plus minus 7 kilograms due to liquids in the car and due to the fact that, of course, those liquids can vary in pressure, mass, and etc., etc. So that is why that rule there is plus minus 7 kilograms. Of course, I'm once again talking about the way that it was designed, the rule itself. The key takeaway I want everyone from this presentation is to think behind the meaning of the rule itself. Why is that? It's because you will face challenges, especially in the motorsport world, where you will have to understand why it was written that way for you to design it correctly and safely. Of course, we have the noise test after this. The noise test is a test for us not to harm the environment with sound pollution, where we test the noise level of the car. The preparation is done by the team itself. We do an idle test where the maximum sound level should be at 103 decibels at idle, and it should be at 110 decibels at specified RPM. I think the travel for the piston is 15.2 centimeters. Of course, I am not sure, as I do not know the regulations, but there is a calculation done by the officials, or the team can do the calculations themselves if they know how to do it. Of course, it's a mathematical calculation. I am skipping also the rain test for now. Brake test procedure, it is a test where we see whether the car's brakes correctly. We cannot let you on track if your car doesn't brake. It's illogical for us, of course, to do it. How the brake test works is basically you accelerate to a certain speed, you hit the brake as hard as you can, and all four wheels must lock, and you need to brake in a straight line. This is important, because if your brake balance is off and you do not brake in a straight line, that means that you have some issues with the pressure in the brakes. Once again, this test was designed for the safety feature of the car itself. The car must the brake test basically verifies the vehicle's ability to come to a complete stop quickly and safely. I am also skipping the autonomous system due to the fact that we do not have an autonomous system nor an EV car. Technical inspection, sticker, and approval. After you finish all the inspections, you get the technical sticker. You get a sticker for every single test that we do on the nose cone of your car. This marks that you have successfully completed the technical inspection process, and the officials, in a sort of way, sign off on the car's safety itself. You should keep your documentation, such as inspection sheets, in the push bar with you or near you at all times. Of course, we mark certain parts, such as the restrictor or the fuel tank, as to keep the competition fair, because teams have a tendency to have a winning mentality, which is good, but we need to keep the competition itself at a certain fact equal for every single one. At the end of the day, it's racing. Re-inspection requirements. On the picture you can see our dear friends from Gdansk with an exploded airbox. Unfortunately for them, at the Alpe Adria competition, they didn't have the best competition, but unlucky for them. If you get any damage on the car during the competition itself to critical systems, you have to go in for a re-inspection. This means that the officials need to recheck the safety and validity of your car. Of course, you can do modifications to certain parts of the car. You can also do modifications. This is not stated in the rules, but competitions usually allow it. You can do modifications to the car itself, to the critical components, with the approval of an official. You want to change an A-arm or something like this to the suspension. Go up to the scrutineering guys, ask for permission. No one will say no, because you are, first of all, students. Second of all, no one wants a team not to drive. We are not against you here. We are here for you to actually go deeper into the world of motorsport, get the grasp understanding of how things work. So changes are allowed with the permission of an official. Remember this, especially during competition days, that you can go to an official, ask him to do modifications. Of course, after the incident has been made, we remove certain stickers, for example, on marked parts or systems that your car is not allowed to drive. The official at pre-inspection on the dynamic events always checks the stickers to make sure that you are rule compliant and that you have passed technical inspection, meaning that you have the right to drive. And of course, officials' discretion is the God rule for us, where officials may require reinspection at any time, basically giving us the power if we deem that you have some sort of advantage, if we deem that you are not rule compliant, if we deem that your car is not safe, we have a right to tell you to come in for reinspection, and you must comply with the officials themselves. Inspection responsible person, the stress guy, the guy that is the most stressed during the competition. This person should be familiar with all of the car's systems, with the car's systems, how to disassemble them, or how to guide the official throughout the whole process of the car inspection. Of course, we as officials do not know your car. We're seeing it for the first time probably that year. So you will be our guide to your car's systems. You will need to have a grasp understanding of how the systems work, of how to guide us through this process, how to show us what we want to see, how to disassemble or dismount certain stuff. Of course, you can always get the responsible person for the certain system, but if your inspection responsible person is familiar with the car, this saves a lot of time, because you're running out of the inspection zone, getting the other person comes in, then you're swapping out again. This is a time-consuming process, which both for you and us is not good, especially in a stressed environment. We are coming to the end of the presentation shortly, so I want to give you a few key takeaways and best practices from the presentation itself. Preparation is key, safety first, and continuous improvement. Of course, come prepared to do the inspection, meaning that all of the people need to know the regulations themselves. The key takeaway from preparation is key is for you to understand the regulation itself and design the part in accordance to your understanding of the regulation itself. You can always send an email to an official at any competition asking for a clarification on the rule itself. Of course, they are not going to answer whether the design is good or not, but they are going to answer you the interpretation of the rule itself. Safety first, of course, prioritize safety in all aspects of the vehicle and your team. Ensure that all your team members are familiar with the protocols and emergency protocols. Of course, in the regulations, in the rules themselves, you will find rules that are safety critical. It is really important that you are familiar with these rules. And continuous improvement, of course, it's the part where you learn to grow. You grow and learn, and you do the process step by step, understanding stuff. Thank you for the attention, and I would like you to ask any questions if you have now, or you can contact me at any time via Basecamp, or you can also send me an email to the one mentioned, a question about the regulations here.
Thank you very much for the presentation.
Yes, of course, no problem. So I am guessing that there are no questions here. And thank you for the kind attention, everyone, and enjoy the evening.